Hello, my name is Jonathan Katz, and today I'm going to present the Google BigQuery platform for data analytics as part of the course of Big Data Analytics at the Harvard Extension School. So what is a BigQuery? BigQuery is relatively an easy tool to administrate. You're required to have a Google Cloud platform to register. You can register for free. It provides a free account for a year with a credit of $300 where it can use for storage, query, and access to various tools. The big advantage of BigQuery from Google is that there's no need to work on administration, meaning there's no much of installation, setting up virtual servers, indexing. It's pretty fast to install or define, register, and go ahead. The pricing is relatively competitive, and it's based on the volume of queries and data that is being administrated. Queries in BigQuery can run very fast, and that's due to the column-oriented database. The queries can scan terabytes in seconds and petabytes in just a matter of minutes. There's a lot of public data available in the BigQuery tool, and you can use it to test it. For my project, the statement of the problem is as follows. The Harvard Extension School may promote students' participation in online classes, and a limited physical capacity of rooms may be an issue. Therefore, scheduling optimization of classes at certain days of the week may help with the capacity constraint. Weather may take a role in students' decision to come to class. It is assumed that climate may have an impact on student motivation to go out of their homes in severe weather conditions. Measurement of precipitation can be analyzed to provide recommendation to the school on the days when higher average precipitations are predicted. Therefore, I would ask two primary questions when I'm going to do my analytics. The first question would be which days on average have the highest precipitation measurement for the spring semester in the Boston area, and this is to help better schedule the weekly classes in the spring semesters. And if there is a global warming trend such as fewer precipitation over the years, that would be considered. The purpose of the project is to demonstrate and analyze big data utilizing the BigQuery. The results will be visualized using the R Studio and Google Data Studio. The code would be done in the R Studio. The dataset used for this project was taken from the Global Historical Climatology Network, and it is an integrated database of climate summaries from land services stationed across the globe. The dataset is available in BigQuery, and for this project I used the daily recordings. You can also download the dataset from the website of the Global Historical Network, but the storage of the data is already built in within BigQuery, so it's easy to use it. There are 254 tables, which represent a table for each year since 1673. And the total is 96.7 gigabyte because it includes data from all across the stations in the world. So therefore there are over 2.6 billion records that are scanned to retrieve the data. So in the next few minutes, I'm going to provide a demonstration about how to create project in Google Cloud Platform. that would eventually enables me to create a BigQuery because you require a project for any BigQuery to store the tables and the queries. Um, Once I retrieve the data, I can set up the R Studio package and also call BigQuery from RStudio because I can organize the data to vectors, and eventually I can box plot to do some further analysis. Finally, I will quickly present the Google Studio tool that enables also to provide some graphs and creating reports by querying to the BigQuery dataset. So the first step is to go to googlecloud.com and create an account. You would be prompted to enter a credit card and go through all the registration steps. At the end of the forms, you would get to the Google Cloud Console, and you would see at the left side that Google Cloud assigned a project default for as my first project, and they provide a project ID with a number. So it is good to copy this number as a reference because you would need to set it up at RStudio later down the road. After creating a project in the Google Cloud, you can open BigQuery by tapping bigquerycloud.com in your browser, and you should automatically logged into the tool if you have already logged in with your credentials to Google Cloud. If not, this will prompt you to enter username and password. As you can see in this console, there is public data, and you can browse through the various stored big data sets that BigQuery made it available for the public. There is also the option to add the data sets by typing new data set under the project name. In this example, I created the weather data set where I'm going to store all my tables and queries under this project subcategory. So for my project, I used the GHCN_D database, which, as you can see, contains tables from many years. And if you click on one of the tables, you would be able to see the various data elements and further details in regards to the table size and the number of rows. If you would like to browse to see the data itself, you can click on the preview tab. For this example, we would filter the precipitation values for the Boston ID. So all the stations names are located under the stations table, and we will search for the Boston by creating the query. So in the BigQuery console, by clicking on the compose query, you would get the query editor where you can enter the SQL standard query. So for my project, I wanted to capture the day of week based on the day field, and what I've done, I got all the years tables merged into one table because I wanted to capture the Boston station and filter the precipitation, so I would be able to get the values for the spring from January until May for every year in that area. So to run the query, I just click on the query button here, and as you can see, the query running, and it captured the number of seconds that it's retrieving the information. So eventually, when the job finished, it shows you the results. So as I stated at the beginning of my presentation, there were 2 billion records, and you can see that the job was completed within less than 12 seconds, and 96.7 gigabytes were processed. You can look into the explanation. This is a nice tool that BigQuery has to show whether in the various stages what was the timing of the processing, so you can optimize the queries by changing the way that you retrieve the information. And you can click on the job information to see when things were done and how many bytes were processed. Should you go with a different subscription, there is also a billing tier that you would be charged for running the queries and storing them in the BigQuery tool. So the first step is to go to googlecloud.com and create an account. You would be prompted to enter a credit card and go through all the registration steps. At the end of the forms, you would get to the Google Cloud Console, and you would see at the left side that Google Cloud assigned a project default for as my first project, and they provide a project ID with a number, so it is good to copy this number as a reference, because you would need to set it up at RStudio later down the road. To set up an interface between BigQuery to R, you need to download from the GitHub website the package for BigQuery. So more instructions are in the paper, but you can also get that from the website. Once everything is downloaded and installed in R, the next step is to define the variables, and for here I defined vectors for 7 days because I want to merge all the vectors to have a box plot. So when I tried to merge all the blocks, I got an error, and the reason that there is an error is because the vectors are not in the same size. When I extracted the data from the website, not every month or week is equal in terms of the days, and as a result you need to clean it in the way that I presented on this slide. So once it's fixed, you can merge all the vectors, and the end result would be a box plot. The box plot will present you the quartiles and the mean by adding a mean point, and this is a good visualization method to a very big data sets where you can see some variability in terms of the precipitation rate among the week based on historical data. So based on that, you may have a prediction that the same trend will occur. So answering the project problem, you may consider to have the classes scheduled early at the beginning of the week if you don't want the student to come to class because there is a relatively higher precipitation expected. Another way to visualize data is to use a tool called Google Data Studio. It is very easy to set it up because it's the same credentials. You need to go to the Google Data Studio website, and the instructions are included within the link on the slide. Once this is set up, you need to make a connection to BigQuery, and it will be very handy at this point to have the data set with the tables saved, so you would have an exact connection to the data you want to retrieve. Once you retrieve the data, you will be able to graph it with very simple tools that presented in the toolbar that you can see on this slide. So the slide shows the precipitation over the years for the measurements in the Boston area, and as you can see in the last 2 decades, you have more and more outliers where there is more occurrences of outliers. So the averages have not really changed, but there are more extreme situations that may indicate possibly on some global warming effect. So in summary, the pros and cons for BigQuery are that, as you could see, very fast the queries are being processed, and that it is relatively low maintenance, no need to do or set up virtual servers, and it is fully managed by Google, and it seems that it's relatively very cheap compared to the other alternative, and you can get a free trial for $300 credit for a year to test it. It has a limited SQL support, When I did my SQL in R, I had a lot of issues because the semantic creates some issues, so there are some workaround around that. There is no really built-in graph interfaces, so you need to pull the data from various systems such as Google Studio or R in order to visualize the graphs and make some assumptions.